Hi, and welcome to the Worldwide Center of Math Think Thursday problem. This week, the problem is, find a number consisting of 9 digits in which each of the digits from 1 to 9 appear only once. The number should satisfy the following. The number should be divisible by 9. If the most right digit is removed, the remaining number should be divisible by 8. If then again the most right digit is removed, the remaining number should be divisible by 7, and etc. and so on, until the last remaining number should be divisible by 1. So to begin, we're just going to define a few things, and I'm going to erase so we have more room on the board. So what we've defined is that the number that we're looking for, the 9-digit number, we can call it G, and its digits are A1 through A9. So G is equal to A1, A2, A3, so on until we get to A9. We can also say that G of 1 is equal to A1, so basically the number that's supposed to be divisible by 1 is equal to A1, and the number that's supposed to be divisible by 2, G2, is equal to A1, A2, and so on and so forth. And now what we can do is kind of sort through and try and figure out how to find which digits are what numbers. So right away, we can actually see that A5 actually has to be 5. So since there are only 5 digits left, if we had G of 5, we would have A1, A2, A3, A4, all the way up to A5. And what we can see is that the only number from 1 to 9 that makes sense for A5 would be 5 itself. G of 5 has to be divisible by 5, and the only way that's possible is if it ends in either a 5 or a 0, and 0 is not an option, so immediately we know that A5 actually has to equal 5. Another thing that we know is that an odd number isn't divisible by an even number. So what that tells us is that G of 2, G of 4, G of 6, and G of 8 all actually have to be even numbers. And what that basically tells us is that in the case of G2, G4, G6, and G8, all of those numbers have to actually end in an even number. So therefore, A2, A4, A6, and A8 all have to be even as well. So what that tells us is that they all have to be either 2, 4, 6, or 8. And we can do kind of a similar thing for the odd numbers, therefore. Since we have 4 even numbers that we've used for G, for A2, A4, A6, and A8, then A1, A3, A7, and A9, therefore, must be the remaining odd numbers. So what that tells us about the number G is that it actually goes, in terms of the digits, it would go odd, even, and so on until we get to 9. Now we can move on to try and actually figure out what these digits are. So moving on to G of 6, so this number A1, A2, A3, A4, A5, A6, we know that this number must be divisible by 6, and what that means is that it has to be even, and it also has to be divisible by 3. And what we can tell actually is that this part, A1, A2, A3, which is also equal to G of 3, by construction has to be divisible by 3. That's kind of how we're solving this problem. So we know that already this part is divisible by 3. So what we can do is see that this part, A4, A5, A6, we construct it to also be divisible by 3 in order to make G of 6 divisible by 6. We also know that a of 5 is actually equal to 5. So to make g of 6 divisible by 6, what we have to do is make a of 4 times 5, since this is a of 5, times a of 6 divisible by 3. So that means that these different digits have to sum to a number that is divisible by 3. Now we know that a4 and a6 have to be even numbers. We know that they have to either be 2, 4, 6, or 8. And what we can see there is adding 5 to these. We can come up with a couple different combinations of the different digits to create a number a4 plus 5 plus a6 that will be divisible by 3. And we have to come up, actually, it comes out to be for all of the different combinations to be equal to 15. So the different number combinations for what this is equal to, a4, a5, a6, comes out to be comes out to be 2, 5, 8, 8, 5, 2, 4, 5, 6, and 6, 5, 4. So these different combinations actually come out to sum to 15, which makes them divisible by 3. And adding that into that, we know that a1, a2, a3 is divisible by 3. g6 is therefore divisible by 6. So now we can move on to try and actually figure out which of these is a better possibility, or which kind of different multiples of them could be possibilities for the actual series of a4, a5, a6. So moving on, what we can see is that G4 by construction has to be divisible by 4. G4 is A1, A2, A3, A4. And from kind of the different rules of numbers, the way we can tell if a number is divisible by 4 is if its last two digits are divisible by 4. So that means that A3, A4 has to be divisible by 4. And we can see from what we've kind of defined above that A3 has to be odd and A4 has to be even. So it's going to be a odd digit, even digit number that has to be divisible by 4. If you actually look at all of the multiples of 4, you'll notice that any multiple that has an odd digit first actually is followed by either a 2 or a 6. So what that tells us is that A4 is either going to be a 2 or a 6. That actually helps us narrow down over here the possibilities for what A4, A5, A6 could be. So we know that therefore 258 is a possibility, 852 is no longer a possibility, 456 is no longer a possibility, and 654 is a possibility. So now we can move on to G of 8, which is A1, A2, A3, A4, A5, A6, A7, A8. We know that G of 8 has to be divisible by 8, and the way you can tell if a number is divisible by 8, if its last three digits are divisible by 8. So A6, A7, A8. But you'll notice that in any of the multiples of 8 and any numbers that actually have a even first of the three digits, so A6, and we know that A6 has to be even. That in that case, you can actually tell if the number is divisible by 8 if its last two digits are then divisible by 8. So since we know that this first number is even, what we have to check is if A7, A8 is divisible by 8. And we can take a similar approach to what we did with finding if the number was divisible by 4. Obviously, from what we've defined, we know that A7 is odd and A8 is even. And we can take the different digits from 1 to 9 and figure out different numbers that could be divisible by 8. And basically what we come up with is that A7, A8 either has to be 16, 32, 72, or 96. And what you'll actually notice from this is that A8, the second digit, is either 6 or 2, which is similar to 4. So what we know is that A4 is either 6 or 2, and that A8 is either 6 or 2. So now we're going to gather what we know and come up with a different, couple of different possibilities for what we know the number possibly could be. So first off, if we say that A4 is 2, what that means is that we know that A6 then has to be 8. If A4 is 2, we can see here A6 has to be 8. And that means A8 would then be 4. Oh, would then be 6, excuse me. What that then also tells us from the different options for what we had for A7 and A8 is that if A8 is 6, then A7 has to either be 1 or 9. If A4 is equal to 6, then we know A6 has to be equal to 4 from here. With A4 equal to 6, A6 then has to be equal to 4. And A8 has to be equal to 2, which would mean that A7 has to be equal to either 3 or 7. So just kind of gathering what we know, this is kind of the two different possibilities for the numbers that we have. And now we kind of can zone in on what the actual number is. So we can now move on to G of 3, which is A1, A2, A3, and we know that must be divisible by 3 by the construction of the problem. So what that means, as we've gone over before, is that A1 plus A2 plus A3, their sum must be a number that is divisible by 3. And we know from kind of the definitions that we've created over here, the numbers that are left for what A2 could be equal to are actually 4 and 8. We know that A4 and A8 have to be 6 and 2. Therefore, A2 has to either be 4 or 8. And from there, what we can kind of figure out is the different possibilities for what G of 3 can equal. There are quite a few different possibilities, so I'll write them all down. And so these are all the possibilities for the numbers, and the way that you can find those numbers is knowing that A1 and A3 have to both be odd, and the options left for what numbers of odd could be are 1, 3, 7, and 9. And we know that A2 has to be either 4 or 8, and trying different combinations of those numbers until they sum to a number that is divisible by 3. So we actually have 10 options for what G of 3 could equal. And right now we're just going to leave it at that and move on to G of 9. So we know that G of 9, which is the full number, just G, has to be divisible by 9. But by construction of that problem, we already know that that's true, regardless of what order you put the digits in. You're going to end up coming out with 1 plus 2 plus 3, so on until you get to 9, which comes out to 45, which is divisible by 9. So already we know that that's true regardless of what order we put the digits in. So now we can actually move on to creating different numbers, and then we'll actually narrow it down to 1 by using g of 7. So using all of the things that we've defined for the different digits and numbers, we actually come up with 10 possible solutions for what the number could equal, but we haven't yet found what G7 is equal to and if the number is divisible by 7. There are 10 numbers, and you actually have to go through and try each one until you find a number, G7, that's divisible by 7. What we actually find, though, is that 3816547 is actually divisible by 7. So what that tells us is that G is equal to 381654729. So that's all we have for you today for this week's Think Thursday problem. I hope you enjoyed watching it. Please check out some more of our videos on YouTube, check us out on Facebook, and follow us on Twitter. Thank you.